All, Vinod here from Entrance Engineering Academy. Before going into the video, I just want to say a few things about Entrance Engineering Academy. So, EEA is an online gate preparation portal, and we offer full course for GATE ME and XE. In addition to that, subject courses are also available for ME, XE, CE, and PI. Engineering mathematics course is available for all stream, and in addition to that, we offer online test series for GATE ME and XE also. So this is our website. You can just check out so that you will get to know more about us. And in addition, we have our own Android app and also iOS app, and you can just go through that also to know more about our courses. Okay. And this is our last year, that is GATE 2021 result from XE. And now let us proceed to the video. And this video is taken from online video course of Endurance Engineering Academy. So let us start projectile motion. Okay, just imagine there is a person, there is a boy, and there is a football. Okay, and just he is kicking that ball. Okay, so there is a football, a person is just kicking that ball. In what path that ball will travel? Obviously it's going to travel, it will reach some maximum distance, again it's going to end, like again it's going to descend, and finally it's going to reach the ground. Consider a cricket man, consider a cricketer who is going to hit the ball. Okay, so what will happen? Obviously the ball will travel in this, similar to this only, it will be traveling in this manner, and then it will either it will go across, like it will go away out of the boundary or inside the boundary, it depends. And consider missile. Okay, so that is also something which is going to travel in a projectile motion only. So all these things will fall under projectile motion. Now we are going to do a small analysis, and we are going to find out a few things which is going to be useful for GATE. Let me say what are the things. The first thing is, imagine there is a person who is kicking the ball. Okay, that is football. What will happen? The ball will travel. It will reach some height, right? And that maximum height the ball has reached. That is the first thing which we need to find out. And then again it's going to come down, and again it's going to hit the ground. What is the velocity at which it is going to hit the ground? That is something which we need to find out. And we need to find out what is the distance between from where he hit it and where it is falling, which is nothing but the total range. See, if you consider throwing a ball, okay, throwing a ball vertically upward, it will reach some maximum distance, again it will come back to the original place. Here there is no range calculation, only maximum distance, and we will calculate what is the velocity at which it will hit back and what is the time taken. But there is no range because the ball is not traveling, right, in a horizontal direction. It is just moving upward and again coming back to original position. But in case of projectile motion, there will be change in the there will be not change in the velocity, there will be change in the distance in horizontal direction also. So we need to find out the maximum distance the ball has reached, range, and what is the velocity at which it is hitting the ground back, and what is the total time taken. Okay, now listen, let us imagine the person is hitting the ball with the initial velocity u, and it is inclined with the horizontal at an angle of theta. Okay, now what will generally happen? The ball will move up, right? The ball will move up, and when it is moving up, and also it's going to move in the horizontal direction. Why it is moving in both the direction? The simple reason, this velocity which is inclined at some angle will have two components, right? One component along the direction, that is one component horizontal component, and another one component vertical component. Horizontal component is simply u cos theta. I already discussed about this, how to resolve the vectors. So u cos theta, okay, is the horizontal component. Let me take it as ux. And vertical component is going to be u sin theta, okay, which is uy. And listen carefully. What about acceleration in x direction and acceleration in y direction? When the ball started to move, okay, when the particle or a ball started to move, what you can observe about the acceleration in y direction? Simple, there is no other factor, we are not considering the air resistance. So only acceleration is acceleration due to gravity. When the ball is moving up, see, due to this velocity u sin theta, that is uy, the ball will try to move up only, right? But acceleration was negative. Why negative? Because acceleration due to gravity will always act downwards, and this velocity is upward. So if I take velocity to be positive, then acceleration opposite direction, so it is negative. So this negative direction, that is acceleration due to gravity, which is negative, it will keep on decreasing the velocity. So what will happen? The ball will start moving upward, but as it is moving upward, velocity will keep on decreasing. Why? Because there is negative acceleration. This is ay, okay, acceleration in y direction. What about acceleration in x direction? This is something which is very important. Acceleration in y direction is very easy to find out, but what about acceleration in x direction? Acceleration in x direction is 0. Was there any component of acceleration in horizontal direction? Nothing, right? Obviously nothing. So just this ball will have same velocity throughout, okay, from here until it reaches here. Horizontal velocity will be same, but vertical velocity will be varying. Why it is varying? Because of the acceleration. So as it start moving in this direction, vertical velocity, that is uy, will be keep on decreasing. Why it is decreasing? Because acceleration is acting in opposite direction, so velocity will keep on decreasing, and once it reaches this point, okay, velocity will become 0, vertical velocity. What about horizontal velocity? It will be still u cos theta only, no change in horizontal velocity. This is happening during ascent. Okay, so this half is ascent, and again this half will be descent, right? We already seen the same concept when I'm throwing the ball up and the ball coming down. Okay, the same concept only. So again, when the ball again like once it reaches 0 velocity, see, let me say like this, Vy is equal to 0, that is final velocity of ascent is 0. And what about initial velocity of descent? Initial velocity of descent will also be 0. So when the ball starts moving down, when the ball starts descending, velocity will be 0, initial velocity. And as it is moving down, we know that acceleration is plus g now, okay, for descent. For descent, acceleration is plus g. So when the ball starts moving down, velocity in y direction will increase. It will be keep on increasing, and when it reaches here, it will have some velocity. What is that? We will find out later. Okay, but horizontal velocity will be, horizontal velocity will never change. From this point throughout this projectile motion, horizontal velocity will never change. Okay. Now, so what are the things I said? I need to find out h max, I need to find out r, I need to find out what is the velocity at which it is hitting. Let me take it as v, and I need to find out time of flight also. Okay, t, let me write it as tf. So time of flight is nothing but time of ascent plus time of descent. So how to find out this? We will use the technique of divide and rule. What is that divide and rule technique? I have to analyze x separately, I will analyze y separately, then I will combine it to get the things. Okay. So first let me start with y. Okay, so what about the analysis in y direction? What are the things which I have in y direction? So let me write. So when we are analyzing y direction, we know that velocity, initial velocity in y direction is u sine theta, and initial acceleration in y direction is minus g, right? So I'm considering the ascent. Okay, in ascent, y direction acceleration is minus g. So if I apply this equation, v square minus u square, that is v square is equal to u square plus 2as, this equation here, what will happen? Final velocity only in y direction. Okay, so final velocity in y direction minus initial velocity in y direction. So final velocity in y direction is 0. I'm considering only the ascent, and initial velocity is u sine theta, only ascent, right? So only ascent, initial velocity is u sine theta. So u square sine square theta, and here in place of acceleration I'm substituting minus g, and s is nothing but h max, right? So from here, that is during the ascent, the total vertical distance was h max only. I'm not worrying about horizontal distance, we are carrying only about vertical distance traveled. So during ascent, the vertical distance traveled was h max. Okay, so u square sine square theta, I will bring this 2g this side, so h max is equal to u square sine square theta by 2g. This is fine, okay, which is very easy and straightforward, well and good. Now, if you are able to recollect something from this, in the last case, that is an object which is thrown up and which is going to come down, in that case, we seen that here instead of u square sine square theta, we had u square by 2g. I hope you could recollect it. Let me write it here. U square by 2g, which is equal to h max in the last case. In this case, it is uy square by 2g. Uy is nothing but u sine theta, right? So u sine theta square is u square sine square theta by 2g. And in the last case, we got u by 2g. Why there is only u? Because there is no horizontal component. Here, horizontal and vertical component both are there. So vertical component square by 2g, initial vertical component square by 2g will give me h max, right? Now coming to next case, that is time taken. How to find out time taken? We can use another equation, right? V is equal to u plus at. I can use this. Since it is y direction, vy is equal to uy, and similarly ay. Okay, so I am finding out time of ascent only. Okay, time of ascent only, that is from here to here. So final velocity of ascent is 0. Okay, final velocity of ascent is 0. Uy, okay, which is nothing but u sine theta plus ay is minus g. During ascent, ay is minus g, and this is going to be ta. So if I rearrange it, ta, that is time taken during the ascent, will be, I will bring u sine theta here, g to the denominator, minus minus will get cancelled. So u sine theta by g, that is ta. Okay, so time of ascent is u sine theta by g. Similarly, time of descent also same only. Okay, ta will be td. Time of ascent and time of descent will be same, which is going to be equal to u sine theta by g. Again, try to recollect it. If I throw a ball up and if it comes down vertically upward, that case we got u by g, right? That case we got u by g. In this case, it is uy by g. Okay, time of ascent. Why it is uy? Because here two direction velocities are there, but there we had only one direction velocity. That is the difference. So let us proceed to the next equation. So we got ta and td, right? And if I add them both, okay, ta plus td, I will be getting time of flight. So u sine theta by g plus u sine theta by g, that is going to result in 2u sine theta by g. Okay, so that is our total time of flight. Now in x direction, okay, in x direction, if I calculate it, ux is going to be u cos theta. That is, in horizontal direction, the velocity is u cos theta, and it will remain constant irrespective of the position. From here until we reach here, everywhere velocity in x direction is u cos theta only. And acceleration in x direction, as I already said, that there is no change in velocity or nothing is going to happen in horizontal direction. So acceleration in horizontal direction is 0. Time of flight for both will remain same only, right? Horizontal or vertical, t will be same only. And now coming to the next thing which I need to find out, that is r. Okay, so how to determine the r? So r, we can find out this total range, right? So we can use this formula. I hope you remember this formula. Ux t plus 1 by 2 ax t square. Okay, which is nothing but ut plus 1 by 2 at square. So since I am finding in horizontal direction, everything has become x. Okay, t is nothing but total time of flight. Ax is acceleration in x direction. We already know that it is 0. Okay, we already know that it is 0, which means this total is going to become 0. So x, which is nothing but range r, which will be equal to ux, which is u cos theta, into t, which is 2 times of u sin theta by g, which is equal to u into 2 cos theta sin theta by g. Okay, so what is 2 cos theta sin theta? We already know that, right? 2 cos theta sin theta is nothing but sin 2 cos theta sin theta is nothing but sin 2 theta, and this u and this u will multiply and it becomes u square. I forgot to mention that, u square into sin 2 theta by g. Okay, so this is x value. Okay, right, so we got the range also. Range is also confirmed. And what about the next thing? We need to find out what is the velocity at which it will strike back. Okay, so that is also going to be very simple. You can apply the equation between this point and this point. Let me erase this formula to find out vy. So vy, that is velocity here. Okay, vy. Okay, so that is going to be equal to uy square. We know that initial velocity during the descent, okay, initial velocity during descent was 0, okay, plus 2 times of acceleration is plus g, okay, acceleration is plus g, okay, into s. S is nothing but the total height, which is h max. So Vy will be 2 times of g into h max. H max we already calculated, u square sine square theta by 2g, right? So these two will get cancelled. I'm sorry, I forgot the square here. Okay, so Vy square is equal to u square sine square theta. So Vy is equal to u sine theta. Okay, so velocity in y direction at the end is u sine theta. So what is the observation you are making? At initial point when I'm striking at a velocity u, horizontal component u cos theta, vertical component u sine theta. When it is reaching, that is when it is reaching the ground back, that time also horizontal component is u cos theta, vertical component is u sine theta. So here v will be u only. Okay, so v is going to be u only. So we calculated everything as of now. Okay, we calculated h max, we calculated range, we calculated what is the velocity at which it is striking back. It is striking back at the same velocity only, and what is the time of flight. Everything has been calculated. Now here I will just alter as I will just do one small analysis. As the ball traveling, when the ball travels from here to here, okay, what will happen to horizontal velocity? No changes, right? It will be u cos theta. But what will happen to vertical velocity? It will decrease. Okay, let me show you like this. It will decrease. Why it is decreasing? Because acceleration is acting downward. Okay, so let me take it as Vy dash. As it moves further, okay, u cos theta won't change at all, horizontal velocity, but this velocity is going to further decrease. Okay, it's further decreasing. As it moves further, once it reaches maximum distance, it becomes 0. Why it is happening? Because as it is moving up, acceleration was acting down, so we are moving against the acceleration, so velocity is decreasing. Now when I am moving down, what will happen? This is something which we already know. In the same point, okay, in the same point horizontal to it, okay, in the same point horizontal to it, anyways, horizontal velocity, there is no change at all. Okay, no issues at all. Horizontal velocity, no change at all. And vertical velocity will have same magnitude but in opposite direction. So it will be having same magnitude, okay, but in opposite direction, a bit more smaller. Okay, and similarly here also same magnitude but in opposite direction, and here also same magnitude only, which is nothing but u sine theta, but this is acting upward, but this is acting downward. So these concepts we discussed yesterday in the last video also, right? Okay, so that's it. That is the conclusion. We'll solve more problems so that you can understand this topic in a much better way. So let us start solving the problems from projectile motion. The first question: in a projectile motion, the velocity is dash, and they're given few statements. First options: always perpendicular to the acceleration. So thus velocity will be always perpendicular to the acceleration. Let us check it out. Okay, so first, how does our projectile motion look? Suppose if this is the ground, and if this is going to be my projectile motion, I'm just giving you an example here. Okay, so let this be maximum point. Okay, the maximum height it could reach. Acceleration will be always acting downwards because it is acceleration due to gravity, so always will be acting downward. Projectile, how it will act? If I am going to project it with a velocity u, there will be two different components. Okay, so one component will be horizontal direction, one will be vertical direction. Okay, so let us just keep this let us just find out how does it looks. Okay, this is horizontal component, this is vertical component. Now if I take this point, horizontal component, each and every point horizontal component is not going to vary in its magnitude, and it will be always like this only, right? And as it is going upward, the vertical component will decrease, and finally at this point vertical component will become 0. We already understood this. And here there will be like again vertical component will increase, and finally it will be same. Okay, whatever the velocity with which I projected, okay, whatever the velocity with which we projected, same velocity it will be hitting back. Now find out whether acceleration due to gravity is always perpendicular to acceleration, like acceleration is always perpendicular to velocity or not. Of course not, it is not always perpendicular, because if you take this point itself, velocity was inclined, right? Velocity was inclined at an angle theta, but acceleration due to gravity is acting downward. So option A is anyways wrong. Now coming to option B, never perpendicular. We cannot say this. Let me just go through all the cases, then we will come back for this option B. Perpendicular to acceleration for one instant and perpendicular to the acceleration for two instant. We can find out that. Of course, here it is not perpendicular, here it is not perpendicular, but here you could see here, right? Acceleration is acting downward. Velocity, there is only one velocity component. U will be equal to ux in this case when it is in the topmost position. Velocity and velocity in x directions are same, and g will be always acting downward, so they will be perpendicular. Okay, so one instant, this is one instant where it is perpendicular. And now here also you could see there are two components. Okay, there are two components of velocity, so my velocity will be in this direction, resultant velocity. Again, my resultant velocity will be here, resultant velocity will be here. So g is always acting downwards, so the resultant velocities are not perpendicular to acceleration due to gravity. So very straightforward question. Okay, option B is also wrong because it is perpendicular at what point? At the maximum height point. So only one instant acceleration and velocities are perpendicular to each other. So option C is correct. So let us proceed to the next question. Two bullets are fired simultaneously horizontally. Okay, so we are firing it. I'm sorry, we are firing it horizontally. Okay, so two bullets are fired simultaneously horizontally with a different speeds. Okay, so let us consider that there is a gun something like this. Okay, you can imagine there is a gun something like this. I am firing a bullet from it. Okay, there is a bullet fired from the gun. Okay, there is another gun. Okay, so there is another, let us consider the velocity of this be ua. Okay, and there is another gun. Okay, another gun, again I am firing another bullet. Okay, so and this bullet, okay, let me just correct it. This bullet was traveling at a velocity uv. Okay, so we are firing it horizontally, so both are fired horizontally only, but with a different speed, as we know that one is having ua speed, another one is ub speed. Now from the same place, again, that is what I just taken both the what is that, both the like both the gun at the same point only. Now both the gun are at the same point means from the ground. Okay, that is from the ground. From the ground, the guns will be at same position only, right? So which means the distance from the ground, let me take it as h. Okay, now the question is which bullet will hit the ground first. So I need to find out whether a will hit the ground first or b will hit the ground first. Now the horizontal velocities are different, I understood, but one thing to note here was the horizontal distance these two bullets are going to travel. They are same, right? For both the cases, they are same. Now, coming to acceleration, okay, acceleration at which it is traveling downwards. Okay, we know very clearly acceleration of bullet B in y direction is going to be equal to acceleration of bullet A in y direction. That is going to be equal to g, because always the bullet will be subjected to acceleration in downward direction, which will be equal to g. Now, right, so distance it is going to travel in y direction is h, distance like acceleration at which it is traveling is g, both the bullets. Now what about velocity with which the bullet A is traveling downward, and similarly what is the velocity at which the bullet A and bullet B traveling downwards, that is in y direction. If you note the things properly, I am applying or I am firing the bullet horizontally, right? So in this direction only. So both the velocities UA and UB will be in horizontal direction. In vertical direction, velocity, I'm sorry, that is velocity. In vertical direction, velocity is going to be zero for both the bullets, not only for one bullet, for both. Okay, velocity in y direction for A and velocity in y direction for B, both are 0. Now just say the answer, which is going to be which is going to be reach the ground first. Okay, which is going to reach the ground first. It's very obvious. Vertical distance is same for both the case. Vertical acceleration is same for both the case. Vertical initial velocities are same for both the case. So the time taken to cover this particular distance will also be same. Okay. So both will reach simultaneously. That is the correct answer. Both will reach simultaneously. Option C. So let us continue for the next question. A buffalo rancher throws a stone over a lake to make the buffaloes come out of the lake. Okay, so there is a buffalo rancher, okay, who is going to throw a stone. Okay, so in a lake, okay, let us consider there is a lake. He is throwing a stone. Let us consider he is standing here. Okay, so he's going to throw a stone. Okay, what should be the angle? Okay, they are asking this angle. Okay, so if he is throwing the stone like this, what is this angle? Okay, the angle at which you should throw the stone so that the range of the stone will be maximum. Range means the distance it is covering in horizontal direction. Okay, we already know the formula for range. What is the formula for range? R is equal to u square sine 2 theta by g. Am I right? So we need to find out when this range will be maximum. Okay, so when I need, what should be the angle theta I need to throw so that this r will be maximum. How can I find out? Very simple. Sine theta. Okay, generally sine theta, sine 2 theta, the value will lie between 0 and 1. Yes, of course, minus 1 to 1, I'm considering only the positive side. So it's going to lie between 0 and 1. Okay. So when this sign, okay, so always it's going to lie between 0 and 1. So only if the sine 2 theta becomes 1. Okay, only when the sine 2 theta becomes 1, r will be maximum. It's very obvious because if sine 2 theta is less than 1, then a value which is smaller, okay, sine 2 theta, a value which is smaller, multiplied with u square by g, it's going to decrease the range further. So for keeping r value maximum, okay, for keeping r value maximum, this sine 2 theta has to be 1. And when sine will be 1, when it is 90 degree, I'm just applying sine inverse on both sides. Okay, so 2 theta will be 90 degree, theta is going to be 45 degrees. So the person, the buffalo rancher, should throw the stone at 45 degree angle so that the stone can cover maximum range. Okay, so how I am doing this? If sine theta is less than 1, obviously r value will decrease, right? Obviously r value will decrease. So for keeping maximum r value, this sine theta has to be 1. Okay. So for so sine 2 theta will be 1. So sine inverse 2 theta will be 90 degrees. So theta is going to be 45 degrees. Okay. So let us continue the next question. The range of a projectile fired at an angle 15 degree. Okay. So range of the projectile when the angle was, okay, so let me just remove this. When the angle was 15 degree. Okay, when the angle was 15 degree, the range is given as 50 meters. Okay, if it is fired at the same speed, which means initial velocity was same, but with a different angle 45 degree. Okay, when the theta is 45 degree, what is going to be the range? That is the question. A very simple question, in fact. We know the basic formula, right? Range is nothing but u square into sine 2 theta by g. Okay, so we know the basic formula, and now from this, okay, from this range is 50 meters. Okay, u square is not known into sine 2 theta. Okay, sine 2 times of theta is 15 degree by g is 10. Okay, which implies u square is equal to 15 to 10 500, 500 by sine 2 times of 15, it is 30. So sine 30. Okay, so all this you will be getting u square. Okay, so sine 30 is 1 by 2. So 1 by 2, if it goes to the numerator, it becomes 2. So 500 into 2, which is 1000. Okay, so u square is 1000. Now coming to this case, range when theta is 45 degrees. That will be what? Simply, they said that initial velocity, same speed, right? So u square is not going to vary into sine of, the angle is given as 45, so sine 45, sine 2 times of 45 by g, which is 10. Okay, u square, which we already know, 1000, sine 2 times of 45, which is sine 90, sine 90 is 1 by 10. So if I cancel this, it becomes 100 meters. Okay, so correct answer for this question is option D, which is 100 meters. So let us proceed to the next question. This is really a very good question. Okay, to be honest, this is a very good question. A popular game in Indian villages is Goli. I hope that most of the village, the students who are the students who are watching the videos from village, they would have played this game. Okay, even in the cities also, during the early time. Okay, during the early time, like in the time of early 2000 or in 1990s or something like that, this game used to be very famous, even in the cities also. Okay, right. So goalie, which is played with the small glass balls called as goalies. I hope that everyone knows this. Okay, if you don't know, just search it in the internet. You will be finding out the image of that. Okay, so there will be some small goalies. Okay, small balls. Okay, a goalie of one player is situated at a distance of 2 meters from goalie of the second player. So if suppose this is one player's goalie, let us imagine this is one player's goalie, another player's goalie is present at a distance of 2 meters. Okay, so it is present at a distance of 2 meters. This second player has to project his goalie by keeping the thumb of the left hand at a place of his goalie. I hope that everyone knows this, right? So he will be projecting it, okay, from some distance. Okay, from some distance he will be projecting it, and they said that if the projected goalie hits the goalie of the first player, then the second player wins. Okay, so from here the first player is going to project it. Okay, this player is going to project it, I'm sorry. The projected goalie hits of the first player. Okay, this is the first player, this is the second player. Okay, so second player is projecting. Okay, second player is projecting, and if this goalie, okay, if this goalie directly hits the first player's goalie, then second player wins. Okay, that is something. And they given that if the height from which the goalie is projected, okay, this height is also given. Okay, the goalie is projected from a height of 19.6 centimeter. So now he is going to project it so that this goalie is going to hit it straight away with some initial velocity is projecting. They didn't say anything about initial velocity, but they given that it's projected horizontally. Okay, so this goalie is going to be projected horizontally. Okay, so with what speed should it be projected so that it directly hits the stationary goalie? So what should be the speed? They are asking this velocity only. What speed it should be projected so that it directly hits the second goalie without falling on the ground earlier. Okay, now how can I proceed? First of all, what are the data which we have? So we have to find out this u. Okay, so since it is projecting in horizontal direction, u will be equal to ux and uy will be 0. There is no velocity in vertical direction, and the given maximum height also, right? So h max is 19.6. You can imagine that this is one off of the projectile. Okay, so we know this is the complete projectile, right? This is the complete projectile. They given one half of the projectile, okay, with some velocity. So they given only this part, okay, only this part of the projectile. We need to find out what is this velocity u. They given h max. They given this distance a range, okay, like it's only half a range. That is what they given that distance also. So what is that? That is given as 2 meters. I will just take it as r, okay, or else you can keep it as just to avoid confusion, I will do something like this. I will take it as x. Okay, so I will take this as y because there is no requirement for you to confuse with this case, right? So let me take this as y. Okay, so this is the total case. Okay, when I'm projecting it here and when it is reaching here, this is only semi case, like half. Okay, so I'm projecting it from the top, and it has to hit this place. Okay, if it has to hit this place, what should be the velocity u with which I need to project it? That is what I need to find out. Okay, so how can I do that? Simple. I can use the basic formula. I know y, which is in centimeter, right? You can convert it into meter. I know x is also, which is 2 meters. So now I need to find out this u. Okay, how can I do? Again, use the same basic equations which we have. Okay, what are the basic equation? It's going to fall with the same acceleration due to gravity, which is g. Okay, constant acceleration due to gravity. So I can use these formulas. V is equal to u plus at, h is equal to ut plus 1 by 2 at square, and v square is equal to u square plus 2as. The problem with these formulas are, I cannot use it directly. I need to use it for y direction, x direction separately. Okay, now if I use it in y direction, okay, if I use it for y direction, what are the things I have in y direction? We already know acceleration, sorry, velocity is 0. Acceleration was g, but minus g because it is acting downwards, so it is minus g. Okay, and I'm sorry, it is plus g only. I'm very sorry. It is plus g only. It is acting downward. It is acting downward, but the motion is also downward, right? So velocity, like the motion is also happening downward. It is like falling case. It is descent case. Okay, in case of descent, acceleration will be plus g only. I'm very sorry. Now we know y. Okay, we know y, so we can use this formula. Okay, y is equal to uyt plus 1 by 2 into ayt square. We already know uy is 0, so this total term will become 0. Y is 19.6, you can convert it into meters, so 19.6 into 10 power minus 2, which is equal to 1 by 2 into acceleration, which is acting downward, which is g. I can take it as 10. Okay, time is t square. So now I will bring all this term to that side, and then I will take square root. I can find out time. So time is 0.198 seconds. See, why I'm finding time? Why I'm finding time? I will say, just wait for a moment. So we got t is equal to 0.198 seconds, right? So this is the time taken for this goalie to reach from this position to this position. Now we can easily find out what is the velocity u. Let me say that. So now we need to find what u, right? We already know u is equal to ux. So by using the formula, okay, by using and also we know x is equal to 2 meters, and we have to find out ux. So what I can do, again I can use the same formula but in x direction. Okay, in x direction, if I use this formula, x is equal to uxt plus 1 by 2 into axt square. But 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 we know acceleration in x direction is 0. Only acceleration is in y direction, which is g. So acceleration in x direction is 0 anyways. So x is going to be, okay, x is going to be ux is what, ux is something which I need to find out. Ux is nothing but u, right? So u into time taken, which is 0.198. And what about x? X is 2 meters. So x will be equal to 2 by 0.198. So that will give me x. Sorry, that will give me. I'm very sorry. I'm very sorry. So x is equal to 2, and that is equal to u into 0.98, right? So u will be equal to 2 by 0.198. Okay, 2 by 0.198. So 2 by 0.198 will be 10.1 meter per second. Okay, so the correct answer here was the velocity. Okay, I'm projecting it in a horizontal direction. U is equal to 10.1 meter per second. Okay.